Hello everyone, welcome to Vijay Codesec. So in today's video we are going to learn about Spark Join. There will be multiple videos on the topic of Spark Join as it is like a very wide concept and it is highly asked interview question. Before starting, please consider subscribing if you haven't subscribed yet. Let's start. So join is basically a wide transformation. If you haven't watched our previous video on narrow transformation versus wide transformation, it would be very difficult for you to understand today's video. I would highly recommend that before watching this video, please watch our narrow transformation versus wide transformation video from the playlist. So, as we know that in wide transformation, shuffling of data occurs. So, to understand join, we must understand how exactly the shuffling of data occurs. For that, let's take an example. Let's assume we have two data sets, df1 and df2. Let's assume the size of data frame 1 is 256 MB and size of data frame 2 is also 256 MB. And in our previous videos, we have seen that a partition in HDFS is of 128 MB. So we will divide it by 128 MB. And hence we will be getting two partitions for each of our data frame. Let's see how these partitions will look like in our executors. This is executor 1. This is executor 2. This is executor 3. So partition 1, partition 2 for data frame 1, and this is partition 1 and partition 2 for data frame 2. Now, as we have understood how our data is spread across the different executors, let's explain it more thoroughly with the help of data. Let's say our DF1 is about employees and DF2 is about the salary of those employees. Let's say we have the employee IDs as, let's say this is how our data is looking like right now. So what will happen is, since we are doing a wide transformation, a join operation, there would be 200 partitions created among the clusters. So since we have like three executors, 200 partitions would be created across these three executors. And now what will happen is, let's assume that we are joining on the basis of where employee.id equal to salary.id. So now, since the IDs are on different executor, to join them we need to bring them in the same executor, same partition. Then only we will be able to join them. So what will happen is, now Spark will be shuffling the data across the executors. And since the number of partitions by default is 200, how Spark will be shuffling is, it would be taking the ID modulo 200, and whatever the number is, it would be putting the data in that partition. So since over here we have like ID is equal to 1, so 1 modulo 200 is equal to 1. So this row would be in the first partition. Similarly, 701 would be in the first partition, and this one would be in the first partition as well. And now it is easy to join the data. That's how Spark joins the data after shuffling, and this is how the shuffling occurs. This is an important concept for join. That's it for today's video. In next video we will be seeing types of join optimization that we can apply in Spark. Thank you for watching.